And how can you find? So we have to find a for which the function f is continuous at every h. So here, let me show you it is a condition for we have the left continuous and right continuous function, and the function f is continuous at, sorry, moment please. What's this one? The function f is continuous at c if the f is continuous from the left. That means the limit of f when x approaches c from the right equals fc, and the limit of f when x approaches c from the left equal f at c. So now let's consider the exercise number 12. I have already received some solution for the exercise number 12. A lot of okay, a lot of the solution for exercise number 12. Okay, now let's see some solution of exercise number 12. So we have to find a for which the function f is continuous at every h. So what do you have now? So exercise number 12. We start with the solution by Lê Bá Vũ.
Teacher, can you record the lesson?
Yeah, I think it is not correct solution for the exercise. So we have the left limit, the left hand limit and the right hand limits for the function f. Okay, moment please. So right hand limit and f continuous at, it should be f is continuous at every h if a equal number 1. I think this is not enough. It's not correct solution for the exercise. You have to talk about when the continuity of f when x is not number 1. Here is he focused only on the x equal number 1. Okay, let me consider some more solution. Okay, moment. This exercise by Lê Bá Vũ. Lê Bá Vũ, ok. Trần Đức Tuấn Kiên. Trần Đức Tuấn Kiên. Okay, he also talked about said about the continuity of f when x is not number 1. So you can say for x less than 1 or x greater than number 1, the function f is continuous. And now we consider the continuity as x equal number 1. So here we have the right hand limit equal to a plus 1 and left hand limit equal number 3. Then f, it should be right. F is continuous. Okay, so continuous is adjective, not the verb. So you should write f is continuous as 1. If and only if the left hand side should be right f1, not fx. Okay, the last one you should write f1, not fx. So we have here a have to be equal number 1. Equal number 1. So let me take Trần Đức Tuấn Kiên. Okay, a moment please. Trần Đức Tuấn Kiên. Trần Đức Tuấn Kiên. Okay, some more exercise. Phạm Hải Nam. Okay, let me check. Phạm Hải Nam. F at 1 equal to A plus 1. F at 1 equal to A plus 1 is correct. And we have the left hand limit. As I said, here we have to also consider the case when x is not number 1. Okay, here he also focused on the point x equal 1 only. So what about the continuity of f when x equal not number 1? Because you see the question here, it should be considered at every x. Okay, so it's something is missing. You should say something about the continuity of f when x equal not number 1. Okay, the exercise is also the solution. Hải Nam Tuấn Kiệt. I think you should write. You should say that f is continuous on the when x less than 1 and x greater than 1. And we have to find the left hand limit and the right hand limit. Okay, so Phạm Tuấn Kiệt gives the correct solution. Phạm Tuấn Kiệt, okay. Phạm Tuấn Kiệt. Đoàn Thế Vinh. Đoàn Thế Vinh is continuous on its domain. Okay, as I said, for the first statement, you should say about the continuity of f when x is not number 1. You can say the f is continuous for x is not number 1. And now let's consider x equal number 1. We have to, this is not correct solution for the you have to find the left hand limit and the right hand limits of the function f. This is not correct solution for the exercise 12. Because maybe the left hand limit is not equal to the function f as x equal 1. So it's not good idea to write x squared plus 2 equal to ax to the power 3 plus 1. Phạm Nhật. Okay, let me check. Phạm Nhật. Phan Đình Nhật. Okay. So you should say f is continuous. Okay, we have to add to be, the verb to be. For possibly f is continuous at every x equivalent to f is continuous at number 1. Okay, you should say about the continuity when f is not number 1. You should say f is continuous for x is not number 1. So f at 1, this is left hand limits, right hand limits. Okay, maybe we can. I'm satisfied with this solution. Okay, so Phạm Đức Thành. Phạm Đức Thành, okay. Phạm Đức Thành.
Phan Đình Nhất thầy ơi.
Sorry, I'm Phan Đình Nhất, okay. Okay, let me take one more solution for this exercise by Phạm Đức Thành. One more. So f is continuous at every x if and only if f left hand limit is. Oh, as I said, most of students. Okay, you can see most students focus the point x equal 1 only. So you should say about the continuity of f when x is not number 1. Okay, you should say, for example, the f is continuous for every x is different from number 1. And then the second step, we consider the continuity as x equal number 1. Phạm Quang Trung. Yeah, okay, this also is similar here. And I said you should say about the continuity when x equal not number 1. F is continued at 1, so therefore it's okay. Most of you don't say about the continuity when x is not number 1. When x is not number 1, we have the function is a polynomial. For example, when x is less than 1, f x equal x squared plus 2 is polynomial, then it is continuous. And f continuous at x equal 1 if and only if a equal 1. So the value of a now equal number 1. I think that's enough for this exercise because there remains a lot of solution for exercise. So we have not enough time to check every solution. Okay, now let me give the hint for this exercise. Okay, so for the first step, you should say about the continuity of f when x is not number 1. You say f is continuous for x is not number 1. So at x equal number 1, we find the left-hand limit and the right-hand limit of f. And f is continuous at number 1 if the left-hand limit equals the right-hand limit, and we find that a equal number 1. Okay, this is exercise number 12. Number 12. So we can do similar for exercise number 13. We have to prove that the function f is continuous on the from the minus infinity to the infinity. So the first step we should say about f is a continuous for OX, for example A. Okay, so the first step. Okay, so what about A? This one. Okay, maybe let me take the number 13. Okay, for the exercise number 13. Okay, so as I said, the first step we should say about the continuity. Okay. So for A, so we say that f is continuous as x or for OH is not number pi over 4. And now we consider the x equal number 4. So for x equal number 4, sorry, pi divided by 4. So we have the left-hand limit, the limit of f. You should give more detail about it. X approach pi over 4 from the left equals the limit of x approach pi over 4 minus fx equals psi x. And z equals psi pi over 4 equal square root of 2 divided by 2. And also the right hand limit we can write here, limit of fx as x approach pi over 4 from the right. So that equal limit here cosine x at x approach pi over 4. So equals a cosine pi over 4. Also equals square root of 2 divided by 2. So it means that this is we denote by f as pi over 4. The left hand minus 0. Okay, equals it is a right hand limit. So from this fact we have then f is continuous. as x equal pi over 4. And in conclusion, we say that f is continued on for OX. Belong to the real number. Okay. This is the solution for exercise number 13a. So I think we can do similar for B. We can do similar for B. So as I said, you should say about the continuity of f when x is not number pi over 4, or the B when x is not number 1. Okay, similar for exercise number 12. So at x equal pi over 4, we consider the left hand limit, the right hand limit, and then we have the condition for the continuity at this point. Let me take some exercise for 13. So there are a lot of the solution for the exercise. So the number 13, Trần Lê Mỹ Linh. Trần Lê Mỹ Linh. Okay, this is why we consider the left hand limit of psi. I think it's still not enough. So we have to prove that f is continuous for on R. So what about the continuity of f when x is equal not number pi over 4? The solution is, don't think about this when x is equal. It's different from pi over 4. Okay, we should say here the left hand limit of f equals the limit when x approach pi over 4 from the left of the function sine. Okay, this one more exercise for A. So f is continued on from this one. So f is continued at pi over 4. Okay, let me check. Okay, this is correct solution for the exercise. So 13. Nguyễn Quý Ngọc. Nguyễn Quý Ngọc. Moment, please. Okay, well done. Nguyễn Quý Ngọc. Dương Nhật Minh. Dương Anh Nhật, sorry. Dương Anh Nhật. Let me check this one. So that's it. H0 such that f H0 equals sine H. Okay, I don't understand the solutions, the answer. Why where the z is H0 such that f at H0 equals sine H0. So what do you want to say? This is not correct. I don't understand the solution. This is not correct solution for the exercise. Okay, let me check one more, please. So here, okay, you should write here the left-hand limit of the function f. Then the left-hand limit equals the limit when x approaches pi over 4 of psi x. Okay, I don't understand why we give the left-hand limit and the right-hand limit of the function sine and cosine. Okay, let me come back to the solution. My solution. Okay, you should see here. Okay, you should write here the limit, the left-hand limit of the function f, and then we have this one. Okay, you should add this one. Don't write only the left-hand limit of the function sine. Where does it come from? Okay, so you should write here also the limit of f equals the right-hand limit of cosine, and then we have this one. You should give more detail about the left-hand limit of the function f and the right-hand limit of the function f. And as I said, we also say about the continuity of f when x is not pi over 4. Okay, I think that's enough for the exercise number 13. We can do similar for exercise B. Okay, we can prove for exercise B. Now let's come back to the exercise sheets. Okay, now let's continue with exercise number 14. 14. Exercise number 14. Locate the discontinuity of the function and illustrate by graphing. So what about A and B? Okay, let's do A and B only. So exercise number 14, A and B only. Okay, let me check some solution for exercise 14, A and B. 14A. So we have two parts. The first part has to look at the discontinuity. That means we find the point where the function f is discontinuity. For this, okay, moment please. Okay, I will show you here. So this one's the 14A, 14. Okay, what about the other at H0? So I think for this exercise, we should say the first step, we should talk about the continuity of f when x is not number 0. Okay, so the first part of you have to locate the discontinuity. Okay, so let me give the maybe I give you the solution for this exercise. Okay. Okay, this is exercise 14. So what is locate? I mean, you have to find the point where the function f is discontinuous. So we say that for A, you should write here f or the function y, the function. You should write the function is continuous at x is not number 0. Okay, and f is discontinuous as x equals 0. And now we can find the left hand limit of the right of f. Left hand limit the limit of y when x approaches 0 from the right. That means it limit here x approaches 0 from the right of 1 over 1 plus e to power 1 over x. So at x approach number 0 from the right, so 1 over x come to the plus infinity. So here equals 0. Okay, and the left hand limit from the left equals the limit of x approach 0 from the left 1 over 1 plus e to power 1 over x. This is equal number when x approach 0 from the left, then e to the power 1 of x approach number 0. So it's equal number 1. So we can say that x equal number 0 is a discontinuity. Point of Taiwan. Okay, we have the left hand limit, the right hand limit, and the sum relation. The sum equal number 1. The sum equal number 1. And here we have the graphing. Okay, we can use the software to plot the. Okay, I will show you now. Okay, here we can use this website where we can plot any function. This function 1 over 1 plus e to the power 1 over x. Okay, so we have this graph. You see from this graph here, you see the left hand limit here. At x approach 0 from the left, so the function is the limit equal number 1. When x approach the 0 from the right, the limit equal number 0. So you see this is a discontinuous point, and the sum relation is number 1. Okay, the difference between the left hand limit and the right hand limit equal number 1. Okay, let me check some more solution for the exercise 14. Okay, for Lê Bá Vũ. Let me check Lê Bá Vũ. Okay, let's check the solution by Lê Bá Vũ. Okay, for A, f is discontinuous when x equals 0. So we should say about y is discontinuous at x equals 0. You should say about the left hand limit and the right hand limit of the function. Nguyễn Nam Hải. So left hand limit equal number 1 and the right hand limit equal number 0. Okay, so we have the graphing function. Okay. Okay, that's correct solution for this exercise 14. Nguyễn Nam Hải. Okay, Nguyễn Nam Hải, please. Any question or remark on this exercise? Okay, this is exercise B. Okay, let me check later. Nguyễn Hữu Chi. I think here should be A should be equal number 0. It's A or 0. So left hand limit. It's not correct. A. What is A? So I think it's enough to say that f is continuous or the function is continuous when x is not number 0. So for the left hand limit, the right hand limit equals 0. A, what is A? A is not 0. Okay, let me check. So it's not good idea to write here the limit of nothing equal 1 over 1 plus e to power in minus infinity. You should don't say the right e to power infinity or e to the power minus infinity. This is an indeterminate form. So you should write here equal number 0 or number 1. That's enough for the left hand limit and the right hand limit. And I should say here's the limit of y. Okay. Bùi Minh Quang, one more. Bùi Minh Quang. F at 0 is not defined. So F at 0 is not defined, then F is not continuous at x equal number 0. So t to the infinity, that's correct. But what about the function f when x equal not number 0? Okay, I don't see about any statement about the continuity when x is not number 0. Because here we have two parts. The first part we have to locate, find the number where the function f is not continuous. So you can see here the solution is don't mention about the continuity of the function when x equal not number 1, so not number 0. And the last one should be number 0, not number 1. Okay, so left hand limit when x approach number 0 from the left and the right, and from 0 not number 1. Okay, I think that's enough for the exercise number 14. Number 14. Any question or remark? Có lẽ thầy trao đổi một chút cái chỗ này. Chúng ta rất nhiều bạn trình bày chưa đạt yêu cầu. Ví dụ chẳng hạn như hỏi yêu cầu là trình bày tìm điều kiện để liên tục trên toàn bộ R thì lại toàn chỉ tập trung vào mỗi điểm x bằng 1 hoặc x bằng 0. Hoặc là viết giới hạn, chúng ta viết giới hạn của trái của hàm sin hoặc hàm cos. Đó là cái gì đấy? Chúng ta viết giới hạn của hàm f chứ, sau đó viết bằng cái giới hạn của hàm sin hàm cos. Tôi thấy rất nhiều bạn trình bày đang có vấn đề. Có lẽ do chúng ta làm cái bài multi choice nhiều quá rồi. Chúng ta làm cái bài trắc nghiệm nhiều, chúng ta chưa cái phần tự luận có vẻ thấy chúng ta đang viết sai nhiều quá, viết lim và không có cái gì cả, và lại bên kia lại không có lim thì viết e mũ vô cùng, như thế là cái dạng vô định, mình không nên viết như thế. Đấy là cái dạng vô định. Thì một số cái lưu ý khi các em làm bài, các em chú ý thầy cái này. Okay, here also it's not good idea to write e to the power infinity because it is an indeterminate form. And f is continuous at every point. If f is continuous at the point 0, then f is not continuous at 0. Okay, what about x is not numbers, x different from 0? Okay, you focus only on the point x equals 0 only. Okay, I think that's enough for the exercise number 14. Okay, let me do one more exercise. Let me do exercise number 15 by myself. Now, number 15, one more exercise number 15. So for number 15, find the number at which f is discontinuous, at which of this number is f continuous from the right, from the left, or neither. Okay, let me do the exercise number 15 by myself and to show you step by step. 15. Okay, let me do this exercise by myself. Okay, the question asks you to find the number at which f is discontinuous. So which number? So for the exercise number A, it depends on the value of C. Okay, so I think the first step for A, number 15, let's do here by myself, A. So we have to find the number at which f is discontinuous. So we say that f is continuous as A is not number 0. So the function is continuous. And now we have to determine whether or not the function is continuous at x equals 0. So we find the left hand limit of f at x approach 0 from the right. So at x approach x is greater than 0, so we use this formula for the function f. Now the function f equal to x plus c. So this limit when x approach 0 from the right equal c. And the left hand limit of f at x approach 0 from the left equal, you can use the formula for the function f to the power x minus 1. So by the particular limit, we can find this equals logarithm of 2. So what we can say is, so we say that if, so we have to consider the two cases. If c equal number logarithm of 2, then we have the left hand limit at 0, limit of f when x approach 0 from the right equals the limit of f at x approach 0 from the left. And the function f is continuous on R. Then f is continuous on R. On the whole real line, okay? So what about the second case? If C is different from logarithm of 2, then what you can say about the function f? So f is discontinuous as x equal number 0. But we see that we have the limit of the function f, limit of f of x at x approach 0 from the right equals c, okay, and equals the f at 0. So in this case, the f is continuous from the right. So the function is continuous, or we can say the right hand limit, right continuous from the right. At x equals 0. Not from the left, because the left hand limit is not equal to the function at number 0. So we have two cases. The first case, if c equal logarithm 2, the function is continuous for all x, and if c is not or is different from the logarithm 2, then the function f is discontinuous at x equals 0, and the function f is continuous from the right at x equals 0. Okay, this is a solution for A. So we can do similar for B. Okay, let me give you the hint for B. So what about the left hand limits for B? So let me give you a hint. So for B, we can find the function f also is B5. The domain is the real line, but f is number 1. Okay, so we have the left hand limit f at 1 minus 0. This is left hand limit equal, we have when x equal number 1, so x equal number 0. And the right hand limit f at 1 plus 0 equal number square root of 1 equal number 1, also equal number f at 1. So the left hand limit is different from the right hand limit, and the function f is discontinuous or not continuous. At x equal number 1. However, f is continuous from the right. From the right. At x equal number 1. Because the right hand limit equal number 1 and equals the function at x equal number 1 equal f1. So the function is continuous from the right at x equal number 1. Okay, this is solution for B. So exercise number 15.
Teacher.
Yeah.
I want to ask about B. If x equal to 0, so it's not continuous too.
No, I think that for this function, f is continuous at every point when x is this is only a hint. It's not a solution. Okay, this is only a hint. Okay, as I said, it's not gives but f is continuous at x equal number 0. Sorry. Okay, let me check at number 0. Okay, one more. Okay, thank you very much. Here I have to check also at x equal number 0. Okay. Maybe we also consider the x equal number 0. Okay, let me check x equal number 0. Okay, we can find the limit of f. Okay, thank you. I had a mistake. This f of x at x approach number 0. So that equals the limit of f. As I said, it is only give you a hint, the idea for the exercise, not the solution. Okay, it's missing. Also, the important point is have to consider the limit of f when x approach number 0. So when x approach number 0 of sine square pi x divided by logarithm of 1 per 2x squared. That equal limit of x approach 0. We can simulate here equal pi x squared. And here we have here's the okay, for this case, I think we can set about the function is not defined at x equals 0. The function is not defined, and then we can we say that the function f is discontinuous at x equals 0. I think that's enough for this exercise. It's not necessary to write down this one. You say here f is not defined. At x equals 0, because here the logarithm, the denominator equal number 0, so f is not defined at x equals 0. Then f is discontinuous. Okay, thank you very much. Okay. So what about the second part? What about the is f continuous from the right as x equals 0? So the question now is f continuous from the left or right at x equals 0. Yes or no?
I think no.
Yeah, no. Why?
Because it doesn't exist. F when x equal to 0.
Yeah, because f is not defined. Okay, it's not defined. Okay, not defined at x equals 0. Okay. So what is the definition of the continuous from the left? Continuous from the left. It means that the left hand limit of f of x at x abroad for example number 0 minus it should be equal number f at 0. But if it's the right hand side, it's not it's the right hand side. It means that the function is not continuous from the left and also from the right. Okay. Thank you. So this is exercise number 15. Okay. I received a lot of solution for the exercise, but we have not enough time to check every to check all the solution. Em gửi đến khá nhiều bài tập nên chắc thầy không check được, chúng ta check được một số bài nên có một số bạn không được check, chúng ta sẽ thiệt thòi một chút, nhưng mà cái đấy là vì thời gian không có nên các em phải chịu vậy. Okay, any question or remark? You have any question or remarks? Okay, before to continue with the derivative of the function, let's do one more exercise. So exercise number 17. One more exercise number 17. Who has idea for the exercise number 17? On the continuity of the function. A train starts at 8 a.m. from Hanoi to Haiphong, arriving at 11 a.m. The next day it starts at 8 a.m. and arrives at 11 a.m. Is there a point on the route the train will cross that's at exactly the same time of day on both days? Who has the idea for the exercise number 17? Okay, let me check here by some. Okay, I will show you. Now exercise number 17. Okay, let me take some of the solutions by Ngọc Minh. Ngọc Minh. So that's the equation of the coordinate for x with respect to the time is f. So that's the point on root fp. I still not get the point. Thầy vẫn chưa thấy cái ý trong cái lời giải này. let me fix. Now we can take the function f minus t. Ft I think is the position point, and t is the time. But I think let's think about the units of the t and ft. Ft is a position, so it's measured in the length or the meter. But t is the time. Các em hiểu F là vị trí, thì là đơn vị đó là mét, T là thời gian, thì tại sao hiệu có hai cái này được? So F, as I said, F is the position of the train. So this is a measure in the, I think, the unit of length, for example, meter, and t is the time. So we cannot take the difference between the ft and t. Yes, understand what I mean? So f is a position of the train, okay? So it's measured in the meter, and t is the time. So cannot take the difference between the time and the length of the distance. So okay, let me check one more solution. This one. Ft is different between the chain and Hanoi. So f multiply f and z or multiply, and f multiply z are continuous or
F and G.
Okay, and z is continuous on f minus z is continuous. So it means that's f. So what is the conclusion?
You should go to the second picture. Is my conclusion.
Okay. Okay, so by intermediate values, so f minus, okay, I'm sorry. Right, it's this one. Okay, so let's ft be the distance between the chain and the Hanoi. That's the first day. The second day. So the f and z are continuous on from the interval. Okay. So f depends on the time t. F minus z of t is continuous. F at 11 equal, what is x?
S is the distance between Hanoi and Haiphong. I forgot to denote it.
So denote x is the distance between. Okay.
Yeah. Sorry.
So x is okay. Let me check at 11 equals 0. Okay, so the function, the difference between f and z takes the negative value and also positive value. Then by the intermediate values theorem, that is the point where the function equals 0. Okay, I think that's correct solution for the exercise number 17.
Yeah.
Nguyễn Đăng Dương.
Nguyễn Mạnh Dương.
Nguyễn Mạnh Dương, sorry.
Yeah.
Nguyễn Mạnh Dương. So we apply the intermediate value theorem for the continuous function. Okay, for the exercise number number 17. Number 17. Okay, let me check where I can find recording. Find in the section. Okay, let me come back to the exercise sheets. And now let's come to the next chapter on the derivative of the function. Exercise sheet here. So exercise numbers. Okay, I let me do one of the exercise for the exercise number 19. So now for the exercise number 19, we have to find the derivative of the function. Okay, so you should remember the rule for differentiation, the sum rule, the difference rule, and the product rule, and the quotient rule for the differentiation. Okay, let me do one of the exercise. For example, exercise number 19. Series 19. For example, let's do the exercise B, for example. So this is a composition function of function psi and tangent of x. So how can you differentiate the function? So we have now the derivative of y with respect to x equal. So the first step, we should differentiate the function psi. We obtain cosine of tangent x. And then we have to multiply by the derivative of the function tangent of x. That's we have here 1 over cosine square. Okay. So we are done. Okay, for B. I think this is not difficult exercise. Maybe yeah, let's do one more exercise for 19. Let's do the exercise 19. Have one more exercise. So now the function is given by the formula. The function y equal fx to the power function gx. So how can you differentiate this function? Let's assume that the function f is positive. So how can you differentiate this function? Okay, to differentiate this function, we can take the logarithm both sides, where the logarithm of y equals c at x multiplied by logarithm of f of x. And now we can differentiate both sides of the equation, of the last equation. Okay, if we differentiate the left-hand side, when we differentiate the logarithm of y, where we consider y as a function of x, so here 1 over y multiplied by the derivative of the function. That means y prime equals the right hand. So it differentiates the right hand. So we have here we apply the product rule. This is the derivative of this function z of x multiplied by logarithm of f of x. Plus here, we keep the function z of x the same, and now we differentiate this function equals the derivative of f divided by f. And now we can multiply both sides with the factor y, so we can find the derivative of the function y. Okay, this is a solution for the exercise number f. And now for this exercise, fx equal, this is fx equal 1 plus 1 over x, and the function z equal x. So in general, we have the function like y equal f to the power gx. So we can differentiate the function by take the logarithm both sides. Okay. Here we assume that f is positive. F is positive. This is exercise number 19. So we can do similar for A, C, D, and E. So there are a lot of exercise. So for some exercise, I give you a hint for the exercise only, not the whole solution for the exercise. Because you see there are a lot of exercise. Okay. Do you have any question or remark on the exercise number 19? So for the exercise number 20, you should remember the equation of the tangent line. You know that the derivative of the function at the point is the slope of the tangent line. So the equation of the tangent line y equal, for example, at A, we have f at A plus the derivative of the function f at A multiplied by x minus A. Okay, this is the equation of the tangent line. Tangent line. So what is a normal line? Okay, I will show you by the. Okay, let me take a picture of this one and go to the. Sorry. What is a normal line and the tangent line? Okay, I will show you now. Okay, here. So you see that we have a curve here, the curve like this one. Okay, so let's consider this point. This point. So what is the tangent line? So the tangent line is a line that's the curve at only one point. Oh, sorry. It's difficult to. Okay, let me make like this one. It's better. Okay, so here we have a point. So what is the tangent line? The tangent line that means a line that's the curve at only one point, or another in other word we can say the line that's the curve at only one point. So it is a tangent line, and the slope of the line equals the derivative of the function at this point. The slope of the tangent line. What is a normal line? The normal line that means a line go through this point and is perpendicular, okay, perpendicular to the tangent line, because the normal line, it is tangent line and the normal line. So what is the slope of the tangent line? Okay, of the normal line, sorry. What is the slope of the equal -1 divided by the derivative of the tangent line. Here we assume that the derivative at A is not 0. This is a normal line and the tangent line. So the normal line, that's a curve at only one point, or they meet the curve at one point only. So that's the curve. And the normal line, what is the normal line? The normal line will go through this point and is perpendicular, okay, perpendicular to the tangent line. Or the angle between two lines equals a right angle. Right angle. And the slope of the the normal line is -1 divided by the derivative of f at a. So we can find the equation of the normal line. So I will show you now the equation. This is the equation of this is the tangent line, the normal line. Is so y equal f at a. Here -1 over the derivative of f at a multiplied by x minus a. This is the equation of the normal line. The equation of the normal line. Okay, let's assume that this point is with coordinate a and fa. This corresponding at a and fa. So we have the equation of the normal line. This is the equation of the normal line. Sorry, the tangent line. And the equation is normal line. The slope of the normal line is -1 divided by the derivative of f at a. Any question or remark on the normal line or tangent line equation? Thầy vừa viết cho các em hai phương trình của tiếp tuyến và pháp tuyến. Có bạn nào có câu hỏi gì không? Okay, we can do the exercise number 20, 21, okay? 22 and 23 relate to the tangent line and the normal line. So let's do by yourself those exercise. Now let's come to the next exercise, exercise number 14. 14. So we have the solution for exercise number 14. It is
Teacher.
yeah.
I taught cắt tuyến in Vietnamese is second in English, and the definition of second is a line that that has two points on the graph.
You mean the?
You said cắt tuyến. Then
Cắt
I
Stop. I mean the name in English. This one. This one. You mean this one? You mean as I said, the line segment connecting 2 points on the graph.
pháp tuyến. Okay.
Normal line. This is normal line.
Yes.
Normal
I
line.
misheard. Yes.
Okay, this normal line is the line go through this point, and the name of the line connecting 2 points on the curve. This line segment here, we call the chalk here, the dây cung. Okay, okay, and this normal line, the normal line, that means the line go through the point and perpendicular with the tangent line. Okay. Okay, well, now let's do one more exercise for today. So exercise number 24. So we have here the definition of what is a differentiable. What is differentiable? So function f is said to be the differentiable at the point when we have here the, okay, let me check here. What does it mean differentiable?
Có đạo hàm.
F is differentiable as f
Khả vi.
is differentiable. If there is a number a, such that we have here the f, okay, at a. So that is capital A, such that f at a plus h equal f at a. Plus here a multiplied by h. Plus here infinitesimal of the higher order than h. This definition of the differentiable at a. And we will see that a will be the derivative of the function f at a. Okay, so this is the definition of the differentiable. The differentiable. Okay, let me take the solution for this exercise 24. Okay, let me check one solution for exercise 24. 24. So you should say f is differentiable. Differentiable is differentiable, okay? But equal to. So f has to be continuous. That's number 2. So 2a equal 4a plus 2b plus 3. So the second part we have to the left derivative and the right left hand derivative equals the right hand derivative at equal number 2. Okay, let me check this one. F at 2 equal 4a plus b. Okay, this is correct. Fx minus a. Let me check this one. 3 minus 4a. Okay, what about the, okay, a, okay, that's correct here. 4a square b. So equal a, so the left hand here equal a. And that means 4a plus b, it should be equal a, so 3a plus b equal 0. So we have here a plus b equal 3 half minus 3 half and 4a plus b. So we get a equal 3 over 4 and b equal minus 9 over 4. Okay, well done. That's correct answer for the exercise 24. So the first condition, the function has to be satisfied. F has to be continuous at this point, and then the left hand derivative equals the right hand derivative at this point. Okay, let me take one more. Nguyễn Quốc Huy. Okay, let me check. Nguyễn Quốc Huy gives a correct solution for the exercise. Nguyễn Quốc Huy. Nguyễn Nam Hải. Okay, let me check my Nguyễn Nam Hải. Okay, this is a continuous function. It's not means the differentiable. Nguyễn Nam Hải. Okay, let me check this one. Okay, so here this is okay, this is a left hand limit and the right hand limit of the derivative, not the right hand derivative. Okay, I will show you now. Let me come back to the word file and I will show you. You have to be distinguish between the two, this one. Moment, please. You have to be careful with this definition. Okay, we have the, so we have to be distinguish between two case. We have here the left hand or the right hand. Derivative. So we can denote by here's f at a, for example. So the tip f at a. We can write here plus here, or some we can use a notation here f at a plus here. So by definition, equal limit here as maybe let me check h plus a from the right, f at a. Sorry, h. You have to be careful with here minus f at a divided by h minus a. So we have another definition here. We have the right hand limit of the f. It means that the limit of the derivative function at x approach a from the right. You should be careful. This is a right hand limit of derivative. And the function f is differentiable. At a, x equal a, if and only if, sorry, the right hand limit, sorry, right hand derivative, that means here we have the f, this is the right hand derivative equals the left hand derivative, or equivalent to the limit at x approach a from the right. Equals the limit left of fx. Okay. Okay, as I said, you should be distinguished between two concepts: the right hand limit and the right hand derivative and the right hand limit of the derivative. It's different. It's different. And you should remember here the condition for the differentiability of the function. So they are different. Okay, they are different. It's not the same. You have to be careful. So if f is a differentiable at a, if and only if the left hand derivative equals the right hand derivative at x equal a. Okay, let me check some more solution for exercise number 24. Huang Minh Huang. Okay, Huang Minh Huang. Let me check this exercise. Okay, Huang Minh Huang, not 21, 24. Okay, let me check some more exercise. Sorry, solution for exercise number 24. Do you need more time for writing? Okay, now let's check some more solution for exercise 24. Hoàng Minh Hoàng. Okay, Nguyễn Nam Hải. Okay, let me check Hoàng Minh Hoàng. Okay, let me check this. This is 21. Okay, 24. Nguyễn Hữu Chí. Okay, so this is a left hand. Sorry, the left hand derivative and the right hand derivative. So I understand about the left hand derivative y equals a. 2a minus 2ax minus 2a divided by x minus 2. Why we have this identity? Nguyễn Hữu Chí. So why we have the left hand limit equal a?
Because dùng triệt tiêu nhỉ? Triệt tiêu x.
Because the function f now equal 4a plus 2b plus 3 not equal to a. You understand what I mean?
No.
The value of the function, the value of function at x equal number 2. It should be equal to the left hand limit. I think it has a mistake on the left hand limit here.
No, when you evaluate the lim x to approach to minus equal.
Okay, from the left, yeah. I mean, this one is not correct. You have to give more explanation where we have 2a minus 2a.
Em có cái đoạn đằng trước nhưng mà em quên chưa chụp cái đoạn đằng trước rồi.
Okay. Okay. You have to explain here the value of f at 2 it should be equal to 2a, because if you understand what I mean. So the value of f at number 2 equal 4a plus 2b plus 3. Okay. So it gives the explanation when
it is also continuous, so it's also equal to a.
And I understand, but you should give the some statement to say about the f at 2. Ok, thầy hiểu ý em rồi, nhưng mà khi mà làm bài thế này là chưa được, bởi vì em viết thay f bằng 2 bằng 2a là không đúng.
Không, cái trang trước của em quên chưa chụp. Tại vì cái nim fx x đến trừ 2 bằng nim fx x đến cộng 2 bằng f2.
That's what I mean, but as I said, I give you some statement here, okay? Because the value of f at x equal to equal 4a plus 2b plus 3. So here we have substitute f2 at equal 4a. Or we can say about the continuity of f at x equal number 2. So let me check here 1a, b, and c. 4a equal a. Okay, so you should give more detail about this exercise. Maybe let's check one more exercise, one more solution. Okay, this is correct, but you should give more detail about what is the left hand derivative, what is the right hand derivative. You should give more detail. This is not solution. I think it's not good idea to write very in short form. Bạn này thì làm quá tắt, cái này không được đâu nha. Nếu mà làm bài thi chúng ta không được. Để giải thích tại sao vậy. Ok. You should give the why we have the left hand derivative and the right hand derivative. And one more, the Hoàng Tiến Doanh. Hoàng Tiến Doanh. So f is differentiable for all value of x equivalent to f is continuous. I think it's so second is that's enough. F is differentiable at x equals 0, that's enough. So it's only for the okay, as I said here, we should give a reason, the more detail about the left hand derivative and the right hand derivative. Why the left hand equal a and the right hand equal 4a plus b. Okay. Nguyễn Quý Ngọc. Okay. Okay, here also maybe it should be 2a here. Okay. So we have from the last system, we should give the solution for the last system. Okay. Nguyễn Quý Ngọc. Quý Ngọc. Okay. Okay, so the function f is differentiable at x equal to if the left hand derivative equals the right hand derivative at x equal number 2. So we find the linear system to find a and b, and then we can find a and b from the system. Okay, so this is exercise number 24. So the time is over. I think we should stop now. Chúng ta nghỉ đã, chúng ta hết giờ. Bạn nào có câu hỏi gì không? Ai có câu hỏi, có trao đổi gì không? Có lẽ thầy giải thích một chút cái này, tức là các em làm có rất nhiều bạn làm được. Tuy nhiên là các em hình dung là khi mà chấm bài hoặc là chúng ta có đọc cái gì chúng ta phải chấm trên những gì các em làm. Một số bạn ví dụ hạn làm nó phải giải thích tại sao f tại 2 nó bằng 2a, cái phải giải thích ra chứ không phải chúng ta chỉ viết. Hoặc một số bạn chỉ viết đạo hàm trái đạo hàm phải mà chả thấy giải thích nó bằng bao nhiêu cả. Như thế đáp án không chấp nhận được, không thể có cái lời giải như thế được.
Thầy, nếu mà mình ghi trước là f liên tục tại 2 thì sau đấy mình có thể thay luôn là f bằng 2a đúng không? Thì tức là lim
nhưng mà tuy nhiên là chúng ta có thể dùng trực tiếp cái tính chất là nó liên tục tại khả vi tại 2 nếu như đạo hàm trái bằng đạo hàm phải thôi, chỉ cần như thế là đủ rồi, không cần phải liên tục đâu.
Vâng.
Nhưng mà vấn đề là em làm vào bài em phải ghi rõ cái ra, nếu em chỉ chép mà cái kia không ấy, thì mình sẽ nói là nó không đúng. Đấy chứ không phải mình muốn nói lại, mình phải nói là em phải viết chi tiết hơn tí nữa. Thì khi mà chấm bài thầy chỉ chấm trên cái bài các em làm ở trên này thôi, chứ không phải là thầy lại khi chấm bài thầy hỏi lại tại sao em làm thế này đó. Cho nên chỗ này em phải nói giải thích tại sao là cái giá trị f tại 2 nó bằng 2a. Thì một số bạn phải làm như thế là chưa đúng. Rồi có bạn thì làm cái đạo hàm trái đạo hàm phải thì viết kết quả luôn thì chả thấy nói gì tại sao nó bằng như thế cả, là không đúng, như thế không được. Ok, còn bạn nào có câu hỏi gì nữa không? Vì chúng ta hết giờ rồi. Có bạn nào còn trao đổi gì nữa không?
Đạo hàm lúc mà đi thi ạ thì phải tính bằng lim hay là tính được bằng công thức đấy ạ?
Nếu như hàm số tại cái điều đầu mút thì phải tính bằng cái giới hạn. Còn nếu bên trong thì chúng ta tính như công thức thôi, bình thường thôi. Bởi vì tại sao như thế? Bởi vì tại cái đầu mút ấy thì cái bình thường giới hạn bên trong là giới hạn hai phía, nhưng mà tại đầu mút em thấy ngay một bên này hàm số có một công thức, bên kia hàm số có một công thức, thì em không thể dùng một cái em phải tính giới hạn trái giới hạn phải hoặc là đạo hàm trái đạo hàm phải để kết luận xem là số có khả vi hay không. Thì đây là cái bài đấy. Cái bài này nó có cái công thức bên trái có công thức nó bằng AXC, bên phải nó một cái hàm khác, và chúng ta muốn tính kiểm tra đạo hàm, ta phải tính đạo hàm trái đạo hàm phải cho nó bằng nhau.
Thầy ơi, tức là Mình muốn làm mà có phải làm theo kiểu trình bày là fx trừ fa trên x trừ a không ấy ạ? Hay là mình được dùng luôn công thức đạo hàm ấy ạ?
À không, tại đầu mút không được dùng công thức đạo hàm, chắc chắn không được dùng luôn, không được dùng luôn. Bởi vì có thể cái giới hạn không tồn tại, không thể dùng như thế được, cái đấy không đúng. Tại đầu mút các em phải viết chi tiết ra theo cái giới hạn mà thầy vẫn làm. Có mấy bài thì làm chi tiết ra rồi đấy. Đây thầy viết rõ ràng đạo hàm trái là phải, hoặc giới hạn trái thì phải viết đầy đủ ra, chứ không thể làm giống như đấy được. Ok, còn bạn nào trao đổi gì nữa không? Thầy không phải nói là cái chuyện là cái đáp số của chúng ta là ok rồi, có rất nhiều bạn làm ý tưởng rất tốt rồi, và vì rất nhiều bạn làm cho nên là mình không thể, tức là chúng ta cố gắng là chúng ta có làm phải chi tiết, tức là phải nói rõ tại sao như thế, chứ không phải là chúng ta vì mà thầy biết cái lời giải rồi nên thầy biết là F2 bằng 2A rồi thì cái đấy nếu em làm như thế là không đúng, đúng không? Em phải giải thích tại sao F2 bằng 2A hay những cái khác như thế. Các em phải tính cụ thể cái đạo hàm trái đạo hàm phải ra, chứ không thể viết ngay cái đạo hàm trái nó bằng 2A còn đạo hàm phải nó bằng cái 4A cộng B được. Cái đấy phải viết rõ ra, chứ không thể viết mỗi công thức như thế không là không đúng. Ok, chúng ta nghỉ rồi. Chào các em, chúng ta nghỉ rồi.
Dạ.